We're going to start with learning how to draw Lewis structures for ions, okay? So the first one we're going to draw is sulfite. What resource can you use to figure out the formula for sulfite? Okay, back at your periodic table. So if you look up sulfite, what's the formula? Okay, SO3 and it has a -2 charge. Okay, so now we're going to keep doing our normal steps. So what's the first thing we add up? Okay, how many valence electrons does sulfur have?
2, 3, 4, 5, 6.
Okay, 6. How many does oxygen have?
6.
Okay. And how many oxygens are there? 3. Okay, now here's a new part. So this time there's a charge. Sulfite has this -2 charge. Does that mean it lost 2 electrons or it gained 2 electrons? Okay, it gained 2. So now when we're adding up electrons, we have to add an additional 2. Okay, so this additional 2 is coming from this -2 charge. You with me there? Okay, so now add that up. What's our new total? 26? Okay, so now this part is going to be pretty much the same that we're used to, except I'm going to add one extra thing at the end. So which atom is going to go in the center? Okay, and then we'll put the oxygens around it. Good, yep. And then off to the right, I'm going to tally. So we started with 26 total. How many electrons have we used in the single bonds?
6.
Okay, so we've used 6. How many do we have left?
20.
Okay, 20. So now let's just start with this oxygen. How many electrons are in the line? 2. How many total does oxygen want? 8. So how many dots do you have to draw?
6.
Okay, 6. And remember to keep them paired up. And are the other oxygens going to be the exact same? Okay, so how many dots do you have to give each oxygen? Okay, so I'm going to go around and give each oxygen 6 dots. Okay. So 6 dots for 3 oxygens. So how many dots did we just draw?
18.
Okay, so how many are left? 2. And then we're going to look at sulfur. Sulfur has 2, 4, 6. And how many total does it want? 8. So how many dots does sulfur need? 2. And we had 2. Okay, so should this be a good structure?
Yes.
Does each element have 8 now?
Yes.
Okay, and did we use all electrons?
Yes.
Okay. The final step for this, since it's an ion, we put ions in brackets. And then the charge of the overall ion is go on the outside like a superscript. Okay, now let's do one more example. This time let's draw nitrate. Again, where can you find the formula for nitrate? Okay, on the back of your periodic table. So look up the formula for nitrate. Okay. NO3 with a -1 charge. Okay. Now what do we do? Good. How many valence electrons does nitrogen have?
5.
Okay. And how many does oxygen have?
6 times 3.
Okay, 6 times 3. And then here's the new part. What does this -1 charge mean?
Plus.
Okay, you got to add 1 because the -1 charge means it gained 1 extra electron. All right, what does this add up to? So this time there's 24 electrons. Which atom will go in the center? Okay, nitrogen. We'll put the oxygens around it. Okay. And then we'll work on our tally. So we started with 24. How many electrons did we use in the single bonds?
6.
Okay, so how many do we have left? Okay, 18. So I'm going to go start with this oxygen again. It has how many here? 2. How many total does it want? So how many dots do you have to add? Okay, and is that going to be the same for all oxygens? Okay, so I'm going to give each oxygen 6. So 6 times 3 is? Okay, so we're out of electrons. Okay, except let's look at nitrogen. Nitrogen only has 2, 4, 6. So is this a good structure?
No.
Okay, so if we're short electrons, what should you be thinking? Okay, double bond. So I'm just going to erase a lone pair. And I'm going to add a double bond. Okay, so now have we used all 24 electrons? Yes. Does each atom have 8 electrons around it? Let's count. So this oxygen has 2, 4, 6, 8. This one has 2, 4, 6, 8. This one has 2, 4, 6, 8. And then nitrogen has 2, 4, 6, 8. Okay. Okay, and then last step, what do you have to put around? Okay, so you got to put your brackets. Minus 1 on the outside. Okay, so now let me ask you a question which will lead into like our next concept. How many of you put the double bond where I put it, between this nitrogen and this oxygen? Just like raise your hand if you put it here. Okay. How many of you put it here, between this nitrogen and this oxygen? Okay. And then how many of you put it over here, between this nitrogen and this oxygen? Okay. Does it matter?
No.
Do we know?
No.
Okay. In real life, do we know? Okay, so when we have this situation where the double bond could have been anywhere, right? You with me? Okay. We call this a resonance structure. Okay. So resonance structures, they are just situations where 2 or more valid electron dot structures exist. Okay. So meaning that double bond could have gone in any position. So here's another example. The double bond, it could go here, it could go here, it could go here. And in reality, it moves. So when you picture electrons in your head, do you picture them as sitting still or do you picture them moving? They're moving. So in one instant in time, the electrons will move and the double bond will be here, but then they constantly move. So in another instant, they'll move and the double bond will form here. And at another instant, they'll move and the double bond will be over here. Okay. So the way we draw that on paper is we draw all possible like valid structures. And then what do you see in between each structure? Arrows, and it's a double-sided arrow, right? So it's just showing that it could really be any of those structures, really at any given time. Okay, so we're going to practice one resonance structure. We're going to draw ozone together. Okay, so ozone is O3. What's the first thing you should do? Okay, how many valence electrons does oxygen have? 6 times 3, so 18. And it's just 3 oxygens, so I'm just going to put 3 in a line. All right, we had 18. How many have we used on the single bonds? Okay. 4, so how many do we have left? Okay, so this oxygen has how many? 2. How many does it want to have? 8. So how many dots do you have to draw? I'm going to draw 6. And then I'm going to jump to the left side. We want to save your last for the center. So this one has how many here? 2. How many total does it want? 8. So how many dots do you have to draw? Give it 6. So then you have 2 left. Where do these final 2 go? Okay, in the middle. Is this a good structure? No, what's wrong? Okay, this one only has 2, 4, 6. So we're short a pair. So what should we be thinking when we're short? Okay, double bond. So I'm just going to erase a lone pair and I'm going to add a double bond. Now, could the double bond just as easily be here?
Yes.
Okay, so when it could be in either spot, what do you have to do? Okay, you draw the resonance structure. Okay, everybody time me. How many seconds is it going to take me to draw the resonance structure?
30 seconds.
Done.
6 seconds.
Okay, so in your head, does it feel like it's so much more work, like I have to draw a whole nother drawing? Maybe. I remember when I was in school, I felt like I had to do so much work. However, that took me how many seconds? 6. So is it really that big of a deal to have to like draw the mirror image? Okay, so I would recommend that don't make this sound like it's the end of the world. In reality, it probably takes you less than 10 seconds. Okay, now we're going to switch gears and talk about exceptions to the octet rule. So again, what is the octet rule?
Every electron is 8.
Okay, so they want 8 except hydrogen. Yeah. Okay, so we're going to cover some exceptions. So one exception, if you have an odd number of valence electrons, can you get one to an even number then? No, right? So if you have an odd number, you're not going to get it to an even 8. Okay. So an example is nitrogen dioxide. So again, what's step 1? Okay. How many valence electrons does nitrogen have? 5. How many does oxygen have? Okay. And how many oxygens are there? Okay. So what is this total? 17. Okay, first, getting an odd number is really rare. Okay. So double check your work, even triple check your work. Okay. Most of the time, if you get an odd number here, it means you made a mistake. Okay. So go back, make sure you didn't make a mistake. Okay. But if you've double checked your work, you've triple checked your work, you know you did it correct, and you know you have an odd number, it just means you're going to break the octet rule. Okay. All right, so at NO2, which one's going to become the central atom?
N.
Okay. N. We'll draw our O's. How many have we used so far?
4.
Okay, 4. So how many are left?
13.
Okay. If we look at this outer oxygen, how many dots does it need to get to 8? Okay, so I'm going to give it 6. How many does this one need to get to 8? Also 6. Okay. So we've used 12. How many are left?
1.
Okay, where does that solo one go? Okay. So then let's count nitrogen. Nitrogen has 2, 4, 5. How many does it want?
8.
8. So even though it's going to break the octet rule, can we do better than 5?
Mm-hmm.
Okay, what number can we get to? 7. Okay. So what can we do to make this one have 7? Double bond. Okay. So I'm going to just erase a lone pair, and I'm going to transfer that to a double bond. Okay, so now it's at 2, 4, 6, 7. Is 7 better than 5?
Yes.
Okay, so we still have to do our best to get it as close to 8 as possible. All right, next we have a couple elements that can be electron deficient, which means they can be stable without 8. Okay. So the 2 that can be stable without 8 are boron and beryllium. Okay, so like write those down, star them. Okay, and they can be stable with 6. And then for our example, I have a typo. It should just be BH3.
Oh.
Okay. All right, so how many valence electrons does boron have? Boron is number 5 up there, but 3 for the column. And then how many can hydrogen have? 1 times 3. So how many total? 6. So then if we look at BH3, which atom goes in the middle? Okay. B, and then spread out the hydrogens. All right, we started with 6. How many electrons did we use? 6. Okay, we're out. We have no more electrons, right? Okay. So is there anything we could do to give boron a full 8?
No.
There's nothing, right? Like there are not enough. So we do have these instances where like we can't double bond, we have no more, and that is okay. Boron is a small atom. It can be stable with just 6. And then last, if atoms can survive with less than 8, can we have the opposite situation where they can survive with more than 8? Okay, so more than 8, we call it an expanded octet. So some atoms can have 10 or 12 electrons. I listed phosphorus, sulfur, silicon, and chlorine. There's more. Okay, so a lot of them can exist with more than 8. And I'll show you the 2 patterns of like how do you know if you're going to expand the octet. So we're going to do these 2 examples together. They're both different, and they're both going to represent the pattern. Okay, so how do we know if the octet gets expanded? So should you do these 2 with me?
Mm-hmm.
Yes. Okay. Our first one is PCl5. What's your first step?
Find the number of valence electrons.
Okay, number of valence electrons. How many does phosphorus have?
5.
5. And what about chlorine?
7.
And how many chlorines are there?
5.
Okay, how many total? Okay. 40. Then which atom is going to go in the middle? Okay. Phosphorus. And then you have to get 5 chlorines around it. Just kind of spread them out the best you can. So then this is our first pattern. Okay, we have PCl5. Right off the bat, does this subscript tell you 5 have to attach to the phosphorus?
Yeah.
Okay, so this is pattern 1. So if this subscript is 5 or higher, you know you're going to break the octet rule. Okay. And then we're just going to finish. We're going to actually draw a valid Lewis structure. Okay, so we started with 40. How many electrons did we use on the single bonds? Okay, 10. So how many do you have left over? 30. Okay, so then pick any chlorine. Chlorine has how many electrons here? 2. How many does it want to have? 8. So how many dots do you have to draw? 6. And are all of the chlorines going to be identical? Okay, so how many dots are you going to add to each chlorine? 6. So I'm going to go around, give each chlorine 6. Okay. So there were 5 chlorines, and they each got 6 dots. So how many dots did I just draw? 30. Okay. So I've used up all of my electrons. My chlorines have 2, 4, 6, 8. So did they fulfill the octet rule? Okay. And then phosphorus, it has 2, 4, 6, 8, 10. But is that okay in this situation? Okay. Yes. So sometimes you can break it. This one, it's pretty obvious because this number is greater than 4. Okay. So you're going to break it. Okay. Questions with that one? Okay. Look at the next one, the xenon tetrafluoride. This one is also going to break it, but it's going to have a different pattern. Okay. So what's our first step? Okay. How many valence electrons does xenon have? Okay. 8. And what about the fluorine? And how many fluorines are there? Okay. So what does that add up to? 36. All right. Which atom goes in the middle? Okay, so I'm going to put xenon in the middle, and then we'll just spread out the fluorines. I'm over here making up elements. All right, then we're going to tally. So we started with 36. How many have we used in the single bonds? Okay. So how many are left? Okay, 28. Fluorine has how many here? 2. How many total does it want to have? 8. So how many dots do you have to give it? Okay. And are all of the fluorines going to be the same? Okay. So I'm going to go give each fluorine 6 dots. What's 6 times 4? Okay. So we placed 24 dots. So how many dots or electrons are left? Okay. 4. So take a look at our structure, though. So fluorine has 2, 4, 6, 8. So that one's good. This one has 2, 4, 6, 8. This one's also good. This one, 2, 4, 6, 8. And the top one, 2, 4, 6, 8. Okay, so fluorines, do they have filled octets? Okay. And then xenon has 2, 4, 6, 8. So does every atom have a filled octet? Okay, here's the problem, though. Can you just make 4 electrons, like, magically disappear? No. Okay, so when you have this scenario, do you still have to place those 4 electrons? Yes. If an atom's going to break the octet rule, it'll always be the central atom. Okay, so it's never going to be one of these outside ones. So it's going to go on xenon. And again, our electrons in pairs or alone? Pairs, so you're just going to give it a pair. I like to spread them out. So maybe like a pair on one side and a pair on the opposite. Is it okay if you did this diagonal? Sure. But you have to draw these final 4 electrons. You can't ignore them. So then the second pattern is you give everything a filled octet, and if you still have remaining electrons left over, do you have to place them? You do, and which atom do they go on? Central atom.